So now we'll be defining the boundaries. First, click on the isometric view, zoom over the intermediate pair. So first we'll be connecting the pair and pair cap arms. So rigid link is basically used to connect nodes of a solid body. So I'll switch over to boundary group name, select substructure as this portion will be activated with the substructure. Click on in this window and then click on this node, top node of pair. So the master node number it will take for the pair top node. And then I'll scroll down, click on the rigid body. So all the 6 degrees of freedom will be restrained. And then the same link has to be created at the other pair location as well. So I'm giving the distance from this pair to that pair in x direction. It is 45 meters. Click on select by window. And then we need to select the 2 nodes of pair caps. And then when we click on apply, we'll find this link will be created over here and it will be copied at the other location as well. So again, when we click on this initial view, so it will undisplay all the links. Switching to again isometric view, zooming over the first abutment location. So now we'll be connecting rigid link for the diaphragm. So basically we'll be connecting the top node of diaphragm with the bottom 2 nodes, bearing top nodes. So switching the boundary group name to construction stage 1 as this portion of diaphragm will be activated in construction stage 1. Then master node will be the top node of the diaphragm. And scrolling down. Now the slave nodes will be the top nodes of the bearings over here. So these 2 are the slave nodes, 21 and 25. And then this has to be copied. This will be copied at the other location, this location as well. And it will be in the same construction stage. So the boundary group remains same. Only we need to give the copy rigid link distance. So this distance is going to be 39.75 from this abutment bearing location to the pair location. We click on apply. So this link gets generated. Same way we will be generating the link for the second intermediate pair. So here we'll zoom a little bit more so that we can select the top nodes of bearings. So I'll just zoom over this portion and then we'll scroll up, change the boundary group name to CS2 as this portion of diaphragm belongs to construction stage 2, and then we'll change the master node number to the top support node of diaphragm as 117, and then we will scroll down and then we will select the top nodes of bearings over here. And then when we click on apply, so this rigid link will be generated. Same way, we will pan to the last abutment location. So for this diaphragm as well, we will change the boundary group name to CS3 as this portion will be activated in construction stage 3. And then the master node number, just click in this box and click on top node of the diaphragm. So it will take it as 158 and then we'll scroll down and again we will select the 2 top nodes of bearings over here and then click on apply. So the rigid link is generated. Again we will just click initial view. So this will switch the view and inactivate all the links which were displayed. I'll close it. Next we'll be defining the elastic links. So I'll switch over to elastic link. So this is used for the bearing definition. So this is the bearing arrangement drawing. So if you see, this is the fixed pair and this is the fixed bearing. This is the transversely free bearing. Then this is the free bearing. This is longitudinally free bearing. So all these bearings we'll be defining in the model. So first we will define this free bearing and we will copy this bearing link to the other 2 locations as well. Same way we will be defining the second bearing over here. So here we will select the boundary group name as sub, as we will activate all the bearing links with the substructure itself. Scroll down. So over here for the first link, which is the free link, we will give SDX value as 1 e raised to power plus 8, 10 raised to power 8 kilonewton per meter as the vertical stiffness of the link. We will just zoom over the free bearing. So this is the bearing, these are the two nodes. So here SDY and SDZ corresponds to the transverse stiffness and longitudinal stiffness of the bearing. SDX is the vertical stiffness. So SDY, I'll give a very less value, that is 10 kilonewton per meter, and SDZ as well, I will just give 10 kilonewton per meter. So the bearing is free to translate in Y and Z direction, as well as free to rotate in any of the directions. Then I will just scroll down. I'll check on this copy elastic link option. So the same link exists at the intermediate pier 2 location as well as abutment location. So in X direction, those distances are 84.75 meters and 39.75 meters. Then for creating this bearing, just click in this two nodes box. Click on the first node and click on the second node. So this generates the bearing. So you can see the axis as well. X is the vertical axis. In the top view, you can see if I just zoom over this bearing. So Y and Z direction are the transverse and longitudinal direction for the bearing. Same way, this bearing is created over here and copied at these two locations. Now I'll switch to again isometric view. I'll zoom over the second bearing location. So these two bearings. Now we will just change the stiffness. So as this bearing is going to be free in longitudinal direction and fixed in transverse direction. So I'm going to give a very high value in SDY direction, which is transverse direction. So I'll change the stiffness to 1e plus 8. So 10 raised to power 8 kilonewton per meter. Then the copying distances are going to be same. I'll click in the two nodes box. Click on the first node and click on the second node. So this link gets generated. Now we will define the fixed bearing. So I'll just zoom over the fixed bearing location. So this is the fixed bearing location. So here again the stiffness in all the three directions are going to be very high. So I'm changing SDZ value to 1e plus 8. And first I need to uncheck this copy elastic link, as I do not want the link to be copied further in X or Y directions. So I'm clicking in this two nodes box and then clicking on the first node of bearing and the second node of bearing. Same way, I'll just pan to the other side of the pier, and here I will change SDY value to 10 kilonewton per meter, as this bearing is going to be free to translate in transverse direction. And then I will just click in this two nodes box and connect the bearing. Then I'll click on close. So this completes the bearing definitions. Then you can click on initial view, this icon. So all the links will be undisplayed. Then finally we'll be defining the supports. So we'll switch to the front view and zoom over the first abutment location. So here I'll be selecting the bottom nodes of the bearings. Again I'll zoom out, I'll zoom in towards the other abutment location, and I'll be selecting the two bottom nodes of the bearings and then the two bottom nodes of two piers. And then I'll go to boundary, define supports option. I'll select the boundary group name as sub, as this will be activated with substructure. I'll restrain all the degrees of freedom, D all and R all, and I'll click on apply. So you can click on initial view and the supports will be undisplayed. Then you can click on close. So this completes the boundary definition.